the motivation of this is an increasing number of attacks on open source projects. So here we don't talk about known accidental vulnerabilities any longer, but about deliberate malicious code injections or malicious code injected by attackers in order to compromise downstream open source consumers. Like 2 years back, while I was still with SAP, we found that there's a lack of a consistent terminology in order to describe all the different attack vectors at the disposal of attackers. And so back then, we developed, together with colleagues from SAP Security Research from the University of Rennes, taxonomy of attacks on open source software supply chains. You have the paper linked in the references below. And this taxonomy basically comprises more than 100 unique attack vectors motivated by real-world incidents. Real-world incidents could be real attacks or vulnerabilities that were luckily discovered before they were exploited, such as vulnerabilities in package repositories, for example. Those attack vectors are linked to plenty of references. We made an effort to use a terminology that is independent of specific programming languages, ecosystems, or technologies. And we covered all the phases from the software development to the build, to the distribution of open source artifacts to consumers. And we ran back then a survey in order to validate this taxonomy and this attack tree, because the taxonomy takes the form of an attack tree by domain experts and developers. And so on top of the taxonomy, we developed a visualization tool. And so the screenshot that you see below is a fork of the existing open source project developed back then at SAP. But rather than letting you try to read this on the slide, I quickly switch to the solution in my browser. So this is the tool. You can explore this attack tree, and for people familiar with the attack tree, the idea is that the parent node, the root node of an attack tree, represents the top level, high level goal of the attacker, which in our case is to conduct an open source supply chain, meaning to deliver malicious code to open source consumers. And then if you expand the tree, you will find techniques to reach this respective top level goal, right? And at the first level, you could either develop a malicious package from scratch and advertise it. You could, as a second technique, as an alternative, create a name confusion with a legitimate established package. And this is, if you expand this, you will find the infamous typo squatting attacks that you have heard about so much in the past, but also other variations of name confusion attacks, such as brand checking, where people just append a well-known brand or company name in front of a package, indicating or suggesting that it comes from a trusted party. And the third sub-technique is to subvert existing resources of a package, which boils down to injecting malicious code into the source code repository while the project is building or when packages are distributed to consumers. So you can expand and explore the tree like this, or you can also just search it in that way. So here we have, for example, abuse of the dependency resolution mechanism, where you find in the reference that this is corresponding to the also prominent attack vector of this dependency confusion found early 2021. On top of that, you basically have here left-hand a description, in the middle the references with some highlights as to whether these are real-world attacks found in the wild, peer-reviewed papers, and so forth. And on the right-hand side, you have safeguards that address, mitigate the respective attack vector partially or completely, with a modal screen showing a little bit more information. That's the Risk Explorer in a nutshell.